Okay, so lots to cover today. My lights are up here. I don't know if you can turn the lights on in the front. How that happened. But anyway, lots to cover today. We're going to be doing the first half of the lecture, like first 45 minutes. I really want to focus on midterm-related stuff. I'm going to first of all talk about the rules, then talk about the material, like what stuff you expected to know. You've now seen what my exams look like. I posted, 1,000 of them or whatever, 4 of them on BSpace, so you see what my exams look like. Of course, the questions you're going to be asked will be different in detail, but that's the basic layout. You get 4 problems. Each one's going to be like have an average of 5 parts. Maybe one will have 6 parts and one will have 3 or whatever. And each part is worth 5 points. All right. And your goal, as I said before, the main thing to learn from it, your goal is to convince the grader you know what you're doing. That's your main goal. Okay. All right. So what are the midterm rules? I've already said an email on this, but just to make it clear, no calculators, calculators, or other, no electronics. No, we've had some crazy things happen in the past. So no electronics. You can use a pencil or a pen. I don't care. I use a pencil. Some students are used to pens because they go up, like in your school system, you're not allowed to use pencils on exams, just to avoid cheating when people look at it later. So yeah, no. But you're allowed to use pencils or pens either way. It's fine. No calculators. Say, oh yes, we do use a blue book. So please bring a blue book. Bring a big one. The big ones are easy. Use more space. Use a big one. You can use a green book if you want. That's fine. Same thing. Bring an extra for your friend. Right. No scratch paper. No textbooks. All right. No text. Okay. No text. No scratch paper. And also, don't write on your blue book when you bring it, all right? Bring it so that it's just blank. Because sometimes what we do is we shuffle them. We have people exchange blue books in the exam beforehand. Because otherwise, some students want to do well in this class and they're tempted to do crazy things. They'll come in with stuff written on their blue books. Don't do that. You want a blank blue book when you come in. You're allowed to bring, though, one single-sided, right? Single-sided, 8.5 by 11. I don't want to, don't bring in like a newspaper size, or a parachute, right? Beside that, or like your clothes. People have all kinds of items. No, it's just one, so single-sided, 8.5 by 11, note page, note sheet. Okay? You can put anything on there you want. Anything on there you want around there is fine. If I were you, though, I would not try to write down every single thing that's in your textbook, every problem you've ever solved, right? Keep it simple. I've had students in the past who'll come with 3 different color pencils, red, blue, so they can write over the same sheet of paper with different colors, they put on different color glasses, and they can read the different. Don't outsmart yourself here, right? The goal here is the main point of making this sheet is not just to have it for the exam. The main point is for you to think about what do I need to know to do well in this class. There's only a few basic ideas in physics. There's not an infinite number of ideas. Small number, much smaller than your chemistry, biology, history, English classes. There's a small number of things you have to know. And so what you want to do on the sheet is put down just the essential things you need to know that you can use to solve any problem. That's the idea, right? So I'm doing you a favor. I know you'll thank me later. Well, some won't. First, I'm only giving you one single side sheet of paper. That forces you to think hard before the exam. You'll do better as a result, actually. When I was your age, I had physics classes. Somebody let us bring nothing. We could come in clothes. That's about it. No pencil. That's it, right? No books, no page, nothing on the exam. As you notice, my exams have some stuff written on them on the front. I have a lot of equations there. You can use those, and they're all true. If you find a typo, let me know. There have been typos in the past. You are responsible to have the right to do the right thing on the exam. Even if I have typos someplace, although I might. Well, anyway, that's only been an issue like a long time ago because those equation sheets have been reviewed now by several semesters, so it's not an issue anymore. Yeah, so you're responsible to get the stuff right. You're allowed to use whatever you have. You're supposed to solve the problems. And I would say also, what can I say about that? One page, no. Oh yeah, don't put everything down. I can't. There's something else I was going to say about that. I got distracted. That crazy idea of going class setting. All right, fine. What else is there to talk about? I think that might be all the rules. No scratch paper. Cal ID. Please bring your picture. Cal ID. We may not need to look at it, but sometimes we need to look at it. So just make sure you've got it on you. And of course, turn off your phone at the beginning. You can have a phone in your pocket. Do not have your phone out during the exam. All right. So that's all pretty obvious stuff. The only thing that might surprise you is no calculators. So that'll cause trouble for some students. Many of you have been using your calculators, of course, to do the homework because mastering physics requires whatever it is, 75 significant figures, and that's really takes very time consuming to do it by hand. So practice a little bit. When you take my practice exams at home, when you practice for the midterm, do it without a calculator, right? Get yourself in shape. Be honest with yourself about what you're fast and slow at. And just get comfortable dividing and multiplying and getting back in the groove doing that stuff. And make sure you write down enough information. So when you solve a homework problem or when you're solving a practice problem before the midterm, write it out. Write every step. Where does this equation come from? Newton's second law, the conservation of energy, where did it come from? Give the grader some clues, right? And don't put anything down that's not true, because it'll be used against you. Even if you get the answer right, you got stuff down that's wrong in the middle, you're gonna lose points, right? It's all about partial credit, and it's all about making it clear to the grader you know what you're doing, right? And I should say also, if you are really clear and you've got lots of really good stuff going on, the grader can tell you know what you're doing. Setting the problem out properly, you're following the right steps, using the right concepts, and then you do make some error. You'll get the benefit of the doubt sometimes when things are ambiguous, or you didn't put down every step toward the end, but you did really well in the beginning. The grader will have a better idea. Yeah, I can see what she was doing in here, and give you the benefit of the doubt. It's judgment call for the grader how to grade these things. It's about partial credit. So what you're trying to do is convey confidence and understanding throughout the whole thing, right? And some students when they deal with, I don't know this problem, I'll put down 5 answers and they're having a half box and there's smudges and stuff, and there's is that a minus sign? There's a mark on the paper. Like you're trying to hedge their bets with multiple. That's not going to help you. Make it clear as you can. Make it clear what your answer is. Box it, and don't have 5 answers and don't have answers on different pages. And like, oh yeah, I did that problem twice. That first time I didn't. If you cross something out, it won't be graded, even if it's right. So if you decide it's wrong, either erase it or cross it out. If you decide it's wrong, but if it's right and you cross it out, you won't get credit. All right, so enough of that kind of stuff. All right, so let me tell you the grading scheme. What is the grading scheme? For every part of every problem, you can get up to 5 points, and this view is 0 points. How's that allocated? Well, 5 points for one of the problems, or for one part of the problem. This is holistic grading. Holistic grading. The phrase we like to phrase, she's got it. That's what the grader is saying. She's doing it. You got everything right, essentially. There may even be a small error someplace. You can still get full credit if there's a mathematics error someplace. Like maybe you multiplied 2 times 5 and got 8 or something. Yeah, get the test. You see me make dumb mistakes in that on the board. But that's a mathematics error. It's not really a physics error. You might get away with that. I'm not guaranteeing it's a judgment call for the grader, right? But what I'm trying to get at is that if there's no real physics error, and if you really have demonstrated understanding, it's clearly written, understand what you're doing, 5 points. She's got it, right? Okay, 4 points is like 1 physics error. So the grader's going through and the grader's saying, if this guy were in my office hours and he's at the board solving the problem, and I could see he understands these things, there's one thing. If I could just ask him, just give him one piece of advice, like how many forces are on that free body diagram, right? What's sort of leading question? Which way does friction point? Right? There's like one error, right? And so what's a physics error? Physics error is the wrong direction for a force under some circumstances. Sometimes you don't know when you set the problem up which way the force should point based on physics reasoning until you solve it. But if you should know ahead of time, then you might get it wrong. If I ask you to draw a free body diagram, I probably will somewhere on the exam. Put all the forces in the free body diagram and have their directions right, Or at least if you don't know which way it's pointing exactly, sometimes you don't know if it's left or right, but you know it's horizontal. Well, then put it in horizontal. Don't have it vertical. If you have a force of gravity that's at an angle, if you have a force of gravity that's horizontal, you're going to lose the point, right? So that's like a physics error. Other physics errors are there's a million of them, right? There's a lot of errors you might make. having the wrong sign for your answer, not giving me a sign. If I say what is the magnitude and direction, tell me the direction too. You'll miss a point if you don't tell me the direction. It could be that you've indicated it on your diagram, but it's not really clear to the grader. The grader has to make a judgment call. Is this really clear? And then they'll, anyway. So give all the answers. Also, I'll talk about this in a minute. What I mean by a finished answer, and what I mean by this number followed. When I have every problem has an answer to it in the form of a number followed by correct units. Right? So I don't have multiple choice on my exams. I don't have because the problem with multiple choice is the smart students can outsmart themselves. Oh, there's an exception, or whatever. They'll think of some way it might. So I don't want to have that happen. Or multiple choice, right? I'd rather have it that you solve problems and then you show me an answer at the end. It's actually less work for you if I say, give me a symbolic answer. I want the answer in terms of V and G or whatever. A lot of students don't like that. They prefer to go all the way to having a number of units, even though it's more work. So I give you guys a little extra work, but it also gives me an opportunity. Gives you an opportunity to show what you know and to check your work. A lot of students, it's easier for them to check their work if it's right. They actually get to a final answer. Yeah. That's right. I'm not going to say it. So it's good practice. It's a good way to ask questions. I would be a fine professor to do such a thing, but I just don't do that typically. I won't do that. Every part of every problem on the exam is going to be, I'm looking for a number, like 5, right, followed by correct units. And one significant figure is all that I really care about, unless otherwise stated, right? So I'm really looking for, I'm trying to make the numbers simple. I'm going to give you numbers like divisions like 10 over 5 and stuff like that. Square root of 25, square root of 16. I'm going to try to make it simple to avoid problems that would be easily calculated but hard by hand. Now, it's hard to do that. I work hard at the exams. I don't always do a perfect job because I want to test a range of material and still make it easy. It's hard to do. I mean easy, but make it so that the algebra is easy. I want the physics to really challenge you. In particular, I want the first part of the problem to be doable by pretty much anybody, even if they've been sleeping through it, right? And the last part to really test the distinguished A and the B students. But it doesn't always work that way. Sometimes what happens is that the middle part of the problem is a little harder. It just depends on what you find hard. It's also the case that some problems will be easier for you and others will be hard, and they may not be in order. So when you take an exam, be smart. Don't get stuck on problem 1B and spend 50 minutes on problem 1B or something, right? If you're spending too much time on one part, mark it and move on and come back to it. Right? Put a little star there, leave yourself some space, come back and finish it later. Sometimes you can solve different parts of the problem in different order. That's often the case. But some things you do need. Oh, that's another thing. I don't want to penalize you for propagating a numerical error. So we'll try not to double charge you if you make a mistake. If the answer is so crazy that when you propagate it, it's clearly unphysical at every stage, you might be double charged for that. And if you make the same mistake over and over, it's a basic physics mistake. Like, I got students come in, oh, you're charging for, I got multiple, double indemnity, or whatever it is. You took points off on part B, part C, part D, because at every stage I used Newton's second law wrong. Well, that's not propagation of an error, that's just lack of understanding about physics, right? So the real issue is we don't want to penalize you if you propagate a factor of 5 mistakes throughout the whole problem. In particular, when I said that it's a judgment call by the grader, if you have a numerical error because of some math error you made, not a physics error, but math error, the real issue there is can you by inspection look at the answer and see that it's not physically meaningful or reasonable, right? Also, if you're off by order of magnitude or more, if you get your exponents wrong, you're probably going to get dinged for that if it's a simple math error because that's a huge error, being wrong by a factor of 10 or more. So make sure you're careful with your algebra, especially when it comes to an exponent. All right, so one physics error, that's 4 points. What's 3 points? Well, that's often due to multiple physics, like 2 or more, multiple physics errors. This is just a sort of general rubric, though. We'll have to deviate from this depending on exactly what the problem does. But this is the basic idea, right? Now let's start at the bottom. Well, if there's nothing right, you're going to get 0. Some professors, nothing correct. Some professors will give you a point for writing something down and encourage you to write something down. I do not want to encourage you to write random things down. I want you to put down stuff that's true and relevant. So nothing correct and relevant. Some graders, relevant. Some graders are more generous than others as to what they think is relevant. But anyway, if you have the beginnings of a plan, oh, sorry, is that true? No, I'm sorry, that's 2. Forget that. One point is at least one correct relevant thing. Okay, so if you have one correct relevant thing written down, you get a point. 2 points, what's that? That's the beginnings of a plan. So you've got Newton's second law written down. Maybe it's not written exactly right, but you label it so they know what you're trying to do, and that is relevant to the problem. And you've got something else written down. You've got a free body diagram indicating some forces, or maybe there's something wrong with it. But so the grader says, yeah, I can see the student is trying to formulate a solution to the problem. Not just like this is happening. You got your cheat sheet. It's got equations on it. There's a V in the problem description. Here's the equation with a V in it. You write it down. Okay, good point. This person's thinking through. Yeah, here's a strategy, but they can't figure it out. They haven't figured out how to solve the problem, but they're making some progress. Now, 3 points could be somebody who finished the whole problem but made a couple physics errors, or made one really major physics error, right? That sometimes is a 3. But a 3 can also be somebody who did a perfect job but didn't finish the problem. So if you have a perfect plan. Right? If you've demonstrated to the grader that, yeah, I know what I'm doing, I've made it to the stage where you can see that I know how to solve the problem, but then the bell rings, hand in your test, didn't get a cheat, or went off to work on another part and never got back to it, or just forgot, right? That's a 3-pointer. You know what you're doing, but you just didn't get it done, right? You didn't finish the problem. Okay, so that's holistic grading. Oh yes, what do I mean by this? What does the correct answer look like? When I say number, it can be a fraction. You can have your answer in the form 10 over 5, meters per second. That's a valid answer. And of course, you might want to do yourself a favor and simplify this and write 2, right? But some students, they wind up with some fractions to test. You can actually leave it this way and still get full credit under most circumstances, as long as the grader can tell what you got. I've seen examples of answers where there's such a big complicated, fractions of fractions of fractions, and some kind of crazy. At some point, you're gonna get dinged, right? Also, if you want to propagate this answer through the next problem and the rest of it, you're doing yourself a favor to simplify it, okay? So you're better off to make it 2. But anyway, the main thing I care about is the clear division between the units and the number. And notice there's no symbols in this expression, right? So sometimes a student will turn the answer and say, oh, it's the mass of the object times 10 meters per second squared or something, divided by 3. Okay, well this is all mixed up, right? There's symbols mixed in, there's units, there's numbers. You're not going to get. That's not a finished answer to the problem. Another thing students do, which is funny, it's funny, so it's not the right way to go, is they'll put down a symbol and then put the units of the symbol after the symbol. The symbol's got the units in it. If M means mass here, because it could be meters in this thing, it's kind of confusing, right? I got M for meter, mass. If this means mass, it's got kilograms buried inside it. So don't put now kilograms after that. You're double counting your units, right? So final answer isn't all mixed up. It's number followed by units. And one more thing I'll say about units. Students will say, does it matter if I write joules or can I write kilogram? What is it, meter squared per second squared? Either of those are perfectly fine, right? Those are each examples of correct units for the same thing. So that's fine. But you can't. On my exams, I won't actually have miles, and I won't have. It'll all be pretty straightforward. I think it'll be meters and kilograms and seconds, right? MKS units. It's not going to be. Calories. It'll be joules, right? It'll be the things you're used to from class. Okay. So and also, somebody asked, we have to write things. So anything you think you might want on the exam, just go ahead and write it on your cheat sheet, on one side of your cheat sheet, or I should call it your formula sheet. It's not cheating, okay? But you also see my exams. You can sort of see the kind of equations you'll see on the front of the exam, on the front of the exam. So whatever you think you might need beyond the sort of things I've written, go ahead and write down. But I try to write the exam so it's self-contained. The goal of the exam, I'm not testing on your memory about I don't know, what the mass of the Earth is, or whatever, or conversion between calories and kilograms. Is that right? Calories and kilograms? How about calories and joules? I'm not testing you on that. What I'm testing you on is your ability to use the formulas that are already written on your sheet to solve problems. Right? Okay, good. Very good. All right. Holistic grading. Right. Okay. Multiple. Right. Good. I think I've hit all my points about that. Primary tat. Right. You bet. All right. It's all about partial credit. Show your work. Convince the grader you know what you're talking about. Okay. So what's the material we're going to cover? I think you can guess. It's all the stuff in chapters 1 through 7. Well, all the stuff. I can't test you on every single thing. Yes. Is it curved? So as I said in the first day class, my first lecture, I'm sort of coy about the details of the grading, but if it gives you pleasure or comfort to think of this as a curved class, you might as well think of it that way, because essentially that's what's going to happen. The distribution of grades in this class is going to be the same as it is, I mean, in my experience. It doesn't matter how I set it up. The real deviation from curve, if there is one, is that I guarantee that anybody who gets 90% or higher as a cumulative course score, right, will get an A in class. So there is an absolute standard. You can sort of just give you some ballpark idea what to shoot for, if you care about A's, or if that's what you're shooting for. I didn't take grades when I was grade. But anyway, I did not take grades. But I loved it. It wouldn't matter. It was in the same thing in class. But if you're shooting for an A, and I know many of you are under pressure to do well and get a good grade, right on, whatever's motivating you is fine. Do a good job. I guarantee that, not on a test-by-test basis, but as an overall class. But that gives you some idea, right? And remember that, if you can phone in the homework and get 100%, right? And if you show up for your labs and you do a decent, I don't want to overstate this, do a good job in your labs. But people tend to do 100%-ish on the homework, a little better, so get some extra credit, or a little below, independent of how, if they just do it, they do pretty well. And if they do pretty well, if they show up in the labs and participate, make a serious effort, that tends to be around 4s and 5s on the labs, right? So you can sort of get an idea. Those things shore up the grade a little bit. So it's a little scarier on the exams than it might be in terms of the overall course score for a typical student. So keep that in mind. But anyway, so I guess the way to say it is, yes, think of it as curved if you like, but have this idea that what you're shooting for is a goal of really, when I say an A student, I mean a student who really is able to do well on all parts of a problem on one of my exams. And if you can still blow it and miss some things here and there, you get 100%, no way, right? But the distinguishing feature is that, like, a B student on my exam will go through and say, okay, the problem about, there's a block and there's an incline. Oh, I'm telling you what's going to be. Anyway, there's going to be something on there, right, like that, and say, oh, that sounds like Newton's second law, and they sort of, stimulus response, like, okay, when I see this problem, here's the formula I apply. And that'll get you pretty far, just saying, okay, this is a problem, this is the type of lie we've almost always used in association with that. But the A student will also see, like, I'll have some problems that are a little trickier, not to fool you or trick you, but to check and see whether you really understand how to use the laws. And if I do my job well, which is a big F, we'll see it in a semester if I do a good job, there won't be a lot of noise on the top. Like, there'll be a really clear distinction between those who really understand the material and those who are working hard, diligently learning the material to the extent that they have, but they aren't. It doesn't like they have a deep understanding. It's more like they know what things go together. Anyway, so this is a long-winded answer to is it curved or not. But that's the fairest answer I can give. That I think it's going to essentially turn out to be as if it were curved. The standard all distribution is always the same. So 350 students, lots of large numbers are, you get a bell curve and good students are on one side and et cetera. Right? Anyway, so I'll continue with material then. If you have more questions, raise your hand. All right, what is material? Well, it's sort of obvious, right? There's probably going to be some kinematic stuff. You might as well know the constant acceleration equations. All right, the first one that you always see, v naught t plus 1/2 at squared. That's just, et cetera, right? I mean, what is this? This is constant acceleration. But there's also a bunch of equations you've got that are generally true. They're more like definitions. What's velocity mean, right? What is the average velocity? Oh, yeah, it's delta x over delta t, et cetera, right? There's all those kind of equations. And then there's the instantaneous equations, like what's acceleration? Oh, it's second derivative of let's call it r instead of x if we're using vectors with respect to time, right? And so on. So the obvious pantheon of equations, right, from that stuff. You should know what gravity. You should know gravity 10 meters per second squared. That's one thing that's going to show up. I'll probably write it on the front of the exam. And you should know what this means and which way gravity points, right, and how to use that. Okay, fine. Projectile motion. So the book has some equations, some sort of ready-made cookbook equations for projectile motion. But they're only valid with certain initial conditions and certain circumstances, right? So some students will rely too heavily on specific equations for particular problems. If the equations written in the book, they obviously important. I'll use that equation. You want to be able to handle a projectile motion problem even if it doesn't conform to a particular set of initial conditions, like the thing starting from zero or starting from rest. I mean to say, you should be able to handle general projectile motion. Right? Projectile motion, which is just an example of constant acceleration. In particular, it's where gravity is pointing straight down, and that's the only thing acting on the body. Right? The acceleration is 10 meters per second squared, straight down. You should know how to handle, relative velocity, right? Just in case that comes up. Relative velocity, the idea that you have some velocity. Maybe this is the velocity of, remember the example, you get an apple with respect to the ground. So you get the signs right. What is that? It's velocity of the apple with respect to the bus, right? Plus the velocity of the bus with respect to the ground, right? Throw an apple forward to the bus. That means that with respect to the ground, it's going faster than with respect to the bus. Right? So that's the basic idea of relative velocity. Circular motion is the other kind of, and I should say one more thing up here. I think you know it, but I'll just remind you, just to know what speed is, right? As opposed to, so the difference between speed and velocity. Speed is just the magnitude of the velocity vector. It's how fast you're moving. But it's the whole, like speed isn't, we break up velocity into the x and the y components, whatever you choose for those, but speed is the whole length of that vector, whatever it is. Don't talk about anyway, so it's the length of that vector, right? Great. It's always a non-zero if zero. It's always non-negative. It can be positive or zero. Circular motion, right? That's a special kind of motion. There's two kinds of circular motion we focused on. One was uniform circular motion. That means constant speed circular motion, right? So if you're going in a circle, and your circle is radius r, and you're moving at some speed v, right? What is the acceleration in that case? What's the magnitude of the acceleration? V squared over r. That's the right units. The only way you can combine v and r, I believe, to get the right units, right? So that was right. Yeah, correct. And for non-uniform circular motion, all that means is you might be speeding up or slowing down, right? In those cases, this is still a useful formula, right? It's just that it's referring to only the component of the acceleration that points toward the center of the circle. So know how to use that stuff. There's probably going to be something about circular motion